Hello friends, welcome back. Today I am back again with another root problem. Actually equation and number of root problem. As you people can see on the screen, I have written the problem and we have to find the number of roots of this equation which lies between close to 0, 2. So I would like to request you people to give yourself a try and then came back to see the solution. Okay, let's begin. So, when we have to solve this kind of problem, that is, we have to find the number of roots of the equation in some given interval, there are some methods which we can follow. The first one of them will be, good choice will be to solve the equation. If we can solve the original equation, then we can easily find out the roots. But sometimes this method does not work. So we have a good guess if we know the Descartes' rule of sign. So we will make a video on Descartes' rule of sign and its application. But when this Descartes' rule of sign fails, there is another good method which we called graphical method. And sometimes it is very useful to use graphical method to solve the question very fast and easily. Now in this equation, if we arrange this equation, you can simply see that the equation will become something like this. See, this is a cubic equation. It's cubic because its highest degree is 3. And I can guarantee that solving a cubic equation is that not easy like a quadratic equation. So if we apply the first method, that is solve the equation, it might be tough. So we can apply Descartes' rule of sign. But if we apply the Descartes' rule of sign, then what we can observe is simply let this equation is fx. If we put some positive sign, that is, if we put the values of x positive, then what will be the first term? It will be the positive, it will be the negative, it will be the positive. So see, there are two sign changes. Two changes. And when we put negative signs in the place of x, the x cube term will be the negative term. This term is always negative, and this term is positive. So there is one change. By this thing, we can guarantee that it is possible that there might be one negative real root. There might be one negative real root and 2 or 0 positive root. Positive real root. But in this method we cannot determine which root lies between 0, 2. Either it will lie or does not lie. Cannot say anything. So now we will apply our last method, we will apply the graphical method. And how can we apply that? Like, look like this. See, f of x is our given thing. It is something like x cube minus 5x square plus 2. If we put x equals to 0, what will be its value? It will be 2. And if we put x equals to 2, what will be its value? See, 2 cube 8, 8 plus 2 10, and this is 4, that is minus 10, right? 2 cube 8, 8 plus 2 10, and this is 2 square 4, 5 into 4 minus 20, because there is a minus 8. 10 minus 20, math is minus 10. So if we draw the graph of this thing, then simply notice that when x equals to 0, it is somewhere here. We don't know at x equals to 1. At x equals to 2, this equation is somehow, this is somehow here. See, this is at x equals to 2 and this is at x equals to, this is at x equals to 2 and this value at x equals to 0. Now, as we can see that f(x) is a polynomial function, so it must be continuous. So, as the graph must be continuous, the graph has to cross the x-axis at least once. At least once. You have to cross the x-axis at least once, otherwise you cannot have the negative value. As you have to cross the x-axis at least once, so we can guarantee that there exists at least one root of this equation in between 0, 2, because we can simply observe that. I don't know what is the root till now, but I can guarantee that there is a root between 0, 2. At least one. There might be more, but at least one. So this graphical method sometimes helps us to find the number of roots and something more. If you find this video useful, then please suggest us to all of your friends, like, comment and do share the video. Thank you.